Okay, well, last time I talked about particles using the more primitive authors API. Today I want to talk about how to do it with Three.js. Let me get a share screen going here. So, as I mentioned, we did area lights, image effects, and custom shaders. We'll talk about particles here today. Particles have their own constructor. They have their own basic material. So we might write a function to create particles that establishes a material, a basic particle material. And then I'll position these particles by making a particle with that material and positioning it. A problem with this is that this doesn't work with WebGL renderer, but instead requires a canvas renderer, which is a whole nother thing. And to work with WebGL renderer, we need to create a particle system. This is analogous to the various mesh objects that have many vertices. Our particle system will have many vertices just like that. So we'll create an array of geometry. Geom, this is creating a new geometry. I'm going to, again, assign a material with the particle basic material. This time I'm going to specify a couple of options. One, their size. They're 4 pixels, 4 units, whatever the units are. I'm going to set the vertex colors to be true. This means that each vertex can have its own color. I have this kind of default color to start with. I'm, of course, going to override that almost immediately. And I'm going to now just scan over X and Y, making a little array of particles in X and Y, basically separated by 1. And I'm going to call this particle a vector with a particular position, 10x, 10y, and 0. And I'm going to push that into my geometry vertices. Geometry is kind of a generic thing with vertices. And here colors, because I set vertex colors to be true, I can assign individual colors. Here I'm just doing a random number between 0 and 1 times a green and blue color. And finally, after creating that geom and that material, I'll make our system with a particle system constructor that takes the geometry, the vertices, and colors of our particles and the material that we're using on these, and I add it to the system just like any other. And that's what this looks like. It's a pretty static picture. We have all these different particles that are 4 units wide. I don't know if that's a pixel or what the unit is here, but there are 4 of them wide. So that's a pretty simple particle system. It's kind of static. The particles don't move. But I can take that particle system and rotate the whole thing. So here's another version of this code. Oops. Sorry. Here's another version of this code, now with a lot of particles, and the particle system is rotating. So the way we're going to do this, first of all, it's basically the same. I've got a function to create particles of a particular size. And I'm now going to add a couple more properties. I'll add transparency and how transparent they are. And I'll also add size attenuation. So my material has a size, a transparency, transparent, vertex colors, either true or false, and size attenuation and color. Before I go further, let me show you what size attenuation does. Here are the particles that I can make a little bigger here. When I turn off size attenuation, they're all the same size. So what size attenuation does is it scales our particle relative to their proximity to the camera. So this is a nice effect that means we don't have to fiddle with the size of the particle as it's further away from our camera. Opacity, if I turn off transparency, the particles are now all opaque. The opacity doesn't affect them, but with transparency on, I can turn down the opacity of the particles and they disappear or become more opaque. And apparently I have a color picker here. I can change the color of my particles. Except that didn't work, did it? That's odd, that didn't work. Sorry about that. Let me reload this. So how do we do this? Well, I'm establishing a geometry. I've established a material that has a certain set of properties, and I'm going to position them in a plus or minus 250 box, assigning a color. I'm going to use two functions, get HSL for hue, saturation, and luminance. And I'm going to use set HSL to set the hue, saturation, and luminance. RGB is one way of looking at colors. Hue, saturation, and luminance is another. Hue is the color, saturation is how heavy that color is, and luminance is kind of a lightness. So I'm going to go through my 15,000 particles that I've got here. I'm going to assign random X, Y, and Z positions to them. I'll call that particle, that vector X, Y, and Z, and I'll push that vector 3 into the vertices of my geometry. The color I'll set to basically a green color here, and a fully saturated green color. And then my hue, saturation, and luminance, I'm going to just get the hue part of get HSL, the S part of HSL, and then I'm going to scale the luminance by a random color between 0 and 1. So this is going to set the color to something with a random luminance. And then I push that color into my geometry. And then I need to create the particle system. So system is a new particle system with the geometry that I just established that has the vertices and colors in it, and the material that has the various properties that I'm going to fiddle with that menu over there on the side. And for reasons that'll become apparent later, I'm going to give it a name too, particles, and add it to the system. So the controls that we're using to redraw this system. First of all, we've got a default size of 4, a transparency of true, an opacity of 0.6. The vertex colors are true. This is our kind of default color. size attenuation is true, rotate system is true. And now I have a redraw function that I'm going to use to update the particle system whenever I change one of the different properties. And this is why I named the particle system. I can go through the scene and get child by name particles. So this finds the particle system in the scene. All of our objects are children of the scene. I'm going to then remove that child object particles if there's one there, and I'm going to create a new particle system that uses the setting of the controls, the setting of the transparency, the setting of the opacity, and so forth. So any property that changes here, I can call the redraw function. It'll remove the current particle system and make a brand new one, which is why anytime I change anything here, it looks completely different, because it's redrawing the entire particle system, removing it, and then recreating it. So the GUI that we see over here has got the size, goes from 0 to 10. And again, as I mentioned, anytime I change these controls, it'll call the redraw function, remove the old particle system, and redraw it. And I do this with the transparency, the opacity, the vertex colors, the color, size attenuation, and rotate system. So when I start this thing, the first thing I do is redraw it. That'll add in all of the default properties here, because redrawing it draws the system. And then I turn it over to render. Render basically just draws things, and everything works just fine. Render, I believe, is almost completely a refresh animate, and a call for the refresh animate. So that's all well and good, but generally we don't move the particle system as a whole, but instead we want to move individual particles. And as long as we're playing with particle systems, let's put a texture on our particle system. Let me close out of that. So here's my snowy scene. I've got a bunch of snowflakes here. And one thing you'll notice here is we have different textures on the different snowflakes. Some of them are six-pointed stars, and some of them are little smudges. And they're moving individually within this snowflake region here. So I'm adding another option to our create system. I'm adding a texture that we're going to add to our system when we create it. Otherwise, everything is pretty much the same. Again, a geometry, again, a color, again, something with the hue, saturation, and luminance. Again, playing with the luminance. The material is basically the same, size, transparent, opacity, but now I'm adding a map, and this is the texture that will display on our particle. And I'm also adding a blending, and I'm also adding a depth right that I'm making false. This is going to be used later when we display these things. I looked up additive blending because I was curious how they did it. It's in ThreeJS, the basic library here. And if blending is additive blending, it means we're enabling the blend. I didn't talk about the blend equation, but there are various functions that you can use. Add is obvious. It adds these together when it combines the blend function. But source alpha and GL1 are what we used with the fire system. So blending goes on. There are a lot of different styles of blending. We're not done with our create system. We need to give our particles random positions. Particle is a vector x, y, z, where we're throwing random numbers in the x, y, and z range. And I'm also going to add to this particle a velocity x, y, and z. Again, random numbers that are going to generate random movement of our particle as it moves around. And I push that particle into the vertices, and I'm ready to make the system. So I create it. I give it a name, which, remember, was one of my new options up here, the name. And I'm going to also specify that the system sort the particles, that this be true. What this does is it requires that the particles are displayed from furthest to closest. And this ensures that the blending of particles will be correct. If they're not sorted in that order, if they don't display from furthest to nearest, when we do our source alpha and GL1, it's whichever one's in front is going to be the source, and so you'll get strange transparency artifacts anytime they're overlapping. But ThreeJS just has an option to sort the particles to be true, and that returns the system. So with this, I can set up several particle systems with a create particles, each with its own texture that I'm going to load with the image utils load texture. So I'm loading snowflake 1, 2, 3, and 4, and 5. I don't know where 4 is. These different snowflakes. And then I'm going to create system 1 with texture 1. All the other things are the same. System 2 with texture 2. All the other things are the same. And I'm going to create all of these, adding them individually to the scene. I want to manipulate these particles, and here in render, I'm going to look through the scene's children, and for each child of the scene, I'll call this function with the child that I've found. And if that child is an instance of a particle system, I'm going to get the vertices out of its geometry. And then for each of those vertices, I'm going to call the function with the argument v, where I'll update each particle's position by its velocity x, y, and z. Then I'm going to reset its position when it falls out the bottom. So if its y coordinate ever drops below 0, I'll set it back up to 60 again. And I also take into account the fact that the particle might hit the wall. And so I'm here in this, I'm bouncing it off the wall by just reversing its x and z velocities when it hits the wall. And of course, we'll update the stats and request anim frame and render it. So that's how our snowflakes work. I can make them bigger. I can make them not transparent. I can change their opacity. I'm not going to fiddle with the color because I'm afraid I'll break that. And the size attenuation on means that those near the camera are bigger, whereas without size attenuation, they're all basically the same size. So that's pretty cool. Okay, so let's try and make a fire. We made a fire with the more primitive authors API. Let's make a fire similar to what we did with that system. One thing I can do here, because Three.js is so much happier in 3 dimensions, is instead of just an X position that puts my fire across the screen, I can actually give it an X and a Z position here. Speed, remember, was the kind of the top of our fire, how high above the fire it goes. And we have a lifetime and an X and Z position that I push into X position, Z position, and my speed. So these are all loaded individually for each particle. They're going to be attributes for a particle. Each particle has a lifetime, an X, a Z position, and a Y speed. I can use the same machinery that I used to make the snowflakes. I've got a size, a transparency, opacity, all those things. I'm going to load the texture particles GIF. Same particle system I used with the author's API. And I'm going to create the system with the texture that I just loaded, size, transparent, opacity, and so forth. Creating the system here, again, just make a geometry material with the various properties. Here's that additive blending again, and the depth right false. With these depth sorted particles, I can now just push them into the geometry, and I make the system, and here's where I specify sorting and return that system that we add to our world. Here's our fire. I'll come back to it in a minute. So the render function works similar to the way we did with the old program. We've got a time that's the current time minus the time that the program started. And here I'm going to go through the scene, all of its children, and for each of those children, I'm going to call the function child, with child as the argument. If child is an instance of a particle system, there are lots of children, cameras, and so forth, but the only one that will trigger here is the one that is a particle system. I, again, get the vertices from the child's geometry vertices, and now I'm going to go through basically what I did in the old program. I'm going to mod time with lifetime of the ith particle, of the ith vertice particle. Here's my TI is 1 minus V life over lifetime of I. I update my positions here, X times TI. TI goes from 1 when it starts to 0 when it's done. So both X and Z are going to come into the center of the fire, and my Y is going to be Y speed times the current lifetime minus 1, so it's going to go up. I did set lifetime to the 4 TI, 1 minus TI, but I don't think I ever figured out how to use it to attenuate the particles. It turns out that the color is a uniform, so I couldn't do anything with that. Vertices, I then assign back from this position that I've updated, and away we go. So I couldn't figure out how to make them fade in and out using the updated V lifetime that I showed here. This thing, I never got to use that. Turns out that opacity appears to be a uniform rather than an attribute, so it applies to all the particles in the system. One other thing I added was a light, top-down spotlight with a color set to match the particle color. And the particle color itself was a uniform as well. So I couldn't really set that randomly either. So I just made a spotlight with the same color. It's some red and some green. That's the thing that saturates and gives us our yellow. The make spotlight function has a color and an intensity, a distance, intensity, its angle, just setting up where it is. The reason I made a function to form a spotlight with various properties was that in the controls, if I changed the color of things, I wanted to also be able to change the color of the light. And so in my redraw function, I'm going to make an array of things to remove. And I'll go through each of the children looking for particle systems. And when I find one, I'll push it into the list of things to remove. And I'll also check to see if the child is a spotlight, in which case I'll also remove it. And then I can go through that list of things to remove for each child in that function to remove. I'll remove it. So that's removing both the particle system and the spotlight that's there. Then I'll make a new spotlight with the updated controls, add the spotlight, make a new particle system with the updated controls. And so I can presumably do things like change the color of my fire here. If I make the size of the particles bigger, they overlap more and I end up with more of this. Transparent just kind of makes them go away, so I don't know what's going on with that. Also size and attenuation kind of makes them go away. So again, I don't know what's going on with that. The light intensity I can presumably turn up and turn down. And I'll take a chance here and change the color. Whoops, I don't want to make it too big. This color should stay in the red-green range, although I think I might be able to change it. There's something wrong with their color picker. I can't get down it. There we go. So here I've got a blue fire. I don't like that. I'll refresh it and make my particles big. So there's our fire in ThreeJS, and I've got the trackball interface on it, so I can look around it from side to side. Pretty cool. So that's the particle systems with ThreeJS, and there's a lot more you can do with it, I'm sure. One thing you might look at in the ThreeJS documentation, there's a color blending advanced that has every possible combination of all of the possible settings for color blending that you can imagine. It's crazy. It's a checkerboard. You can't really see them because there's so many to look at. So I'm going to stop the recording now. I'll see you in class. Have fun. Bye.